Hi everybody, welcome to my channel Numbers with Nora. For this video, I'm going to be going over geometry final. In specifics, I'm going to be going over the LCM2 S2 final study guide. Shout out to one of my 2Ds. She sent me this file to help her study for her geometry final. And if you are studying for your geometry final, I'm going to try to get through all of these. For right now, I'm going to start at 7, and I'm going to go through 7 through 10 on this video, okay? So let's go. So the first one, number 7, using the figure below, choose the appropriate value for sine of theta. So for this one, we're going to be using our trig identities. Again, go back on some of my videos if you don't remember your trig identities, but for all your tests, if you don't remember them, you can always use SOHCAHTOA. Okay, so sine is op over height. Cosine is adjacent in height. And then the TOA is tangent, op and adjacent. Okay, so you can write that down if you don't remember your trig identities, okay? Because we're going to be using it for, I think, 7 through 10 for this one. All right, so for this one, they give us an angle, all right? We know this is going to be the corresponding angle for that one, so this is also going to be our theta. And we have to find sine of this. So sine, remember, sine of the angle that's given, our theta, is going to be op, our opposite side of the angle that's given, over our height, okay, hypotenuse. So the first thing I want to do is I want to annotate all my angles and sides. This one's going to be the opposite. So the opposite of this side is height. Or I'm sorry, I jumped way too quick into it. So the first one we can identify, the easiest one is going to be the angle that's our 90-degree angle. And across from our 90-degree angle is always going to be our hypotenuse. The angle that's given across from that is going to be our op, or opposite side. And then our leftover side is just going to be our adjacent. Okay. Cool. So now that we have that marked up and we have our trig identity, we can go ahead and sit there and substitute everything in. So our sine of our angle that's given, which is noted as theta, is going to equal 65 over our hypotenuse, which is 97, which is what they asked for. So our answer for this one is going to be A. Okay, if you have any questions on how I got that or need more explanation, leave a comment and I will be happy to help you more. For 8, a fountain is located between two 60 feet tall trees. From the base of the fountain, the angles of elevation to the top of each tree is 64 degrees and 48 degrees. Choose the appropriate value for the distance between the two trees. So when they give you something like this, it's always best to draw something out so you can envision what's going on. So I have 2 trees. All right. And then we'll say our fountain. This will be our fountain, okay? They say from the base of the fountain, the angles of elevation to the top of each tree is 64 and 48. So from the top looking down, of each tree, okay? Now, if you always get confused with your angles of elevation, oops. Sorry, I erased a little bit too much. Oh, that's perfect. So if you get confused with your angles of elevation, I always like to sit there and look at it like this. Your angle of elevation is going to be like looking up, okay? And that's going to be this angle. Your angle of depression, which we're going to look at, I believe in number 9 or 10, is when you're kind of looking like down like this, okay? You can go ahead and take a screenshot of this or notate like the angle of depression and elevation and what they look like. All right. So our angle of elevation right here, it's kind of like the one looking up, like in our photo, between here, the ground, and looking up. It's going to be right here and right here. Now they say it's 64 and 48. That's fine. Doesn't matter which one. They didn't tell us which one. So I'm just going to annotate it like that, 64 degrees and 48 degrees. And they also did give us the height of each tree, which I believe is 60. Yeah, 60 feet tall. So that's 60, and this is 60. Okay. And of course, that's feet, but just for the sake of time, I'm not going to annotate that. So again, we're going to sit there and use our trig functions, all right, to sit there and help us out. So the tree is going straight down and hitting the ground. We're going to assume it's a 90-degree angle. Going straight down, hitting the ground, we're going to assume that's our 90-degree angle. So across from here, that's our hypotenuse. Hype. Again, across from this 90-degree angle, that's my height. Now we're going to sit there and identify our opposite side. Our opposite side is opposite of the angle they gave us. They gave us that this angle is 64 degrees. So this is going to be my op. Again, they gave us that 48 degrees. So across from that 48 degrees, that's going to be my op. And now the bases, the ones left, these are going to be our adjacents, okay? And since we don't know those, but we want to find them, we can name these X and Y, okay? Just unknown variables, okay? So I'll name this side X, okay? And that's just the space. And this space right here, that's going to be Y. Now we have to sit there and set up our trig functions to set that up. It's going to be, again, remember, always go back to SOHCAHTOA, all right, if you don't remember your trig identities. So for this one, I'm trying to find my adjacent and I'm giving my opposite. So you look at what trig function deals with opposite and adjacent, that's going to be tangent, okay? So then I get tan of the angle I'm given, which is 64. Equals, and I set up my op over adjacent, so 60 over x. And let's go ahead and set up the other one. Again, I'm looking for my adjacent and op on this triangle. So I do it again. I'm going to use tangent of the angle that they gave me, which is 48 degrees. 48. And again, that equals my op over adjacent. My op is 60. My adjacent, I don't know. I'm trying to find it, and I identified it as y. So now I'm just going to go ahead and use geometry and sit there and solve down so I isolate my variables. Okay, so let's isolate the x first. To isolate my x, I'm going to sit there and multiply both sides by x. Okay, now this is just basic algebra. If you don't understand how I'm isolating my variable, again, leave me a comment and I will explain. And so 64 equals 60. 60. Now I'm going to sit there and divide both sides by my tan of 64. Okay. So those will cancel out on this side. Tan 64. Again, divided by tan of 64. And 64. And like I said, that's going to cancel out on that side. So then my x will be nice and isolated. So this cancels out. That cancels out. Now it's just going to be calculator work. If I do this in my calculator, if you have a basic scientific calculator, always make sure that your calculator, if you have a scientific calculator, always make sure that your calculator is going to be in degrees. And then you just go ahead and plug and chug in your calculator. So I do 60 divided by 64 tan. All right, that's going to be 29.2639. That sounds about right. And since they didn't tell me how to round, what I like to do is after my decimal point, I like to at least write out 4 numbers after my decimal point so I can go ahead and get it right because we're going to have to add these 2 at the end. Okay. So let's go ahead and do the same thing for here. I'm going to get y because I multiply both sides by y. So I get y of tan 48 equals 60. Sorry, this pen is like dying on me a little bit. 60. And then again, I divide both sides by tan of 48. Tan of 48. Divide both sides by tan of 48. Tan of 48. Okay. And again, these cancel out. My y is isolated. So right here, y is going to equal, again, if you do this in your calculator, make sure you're in degrees. I do 60 divided by 48. Tan, which equals 54. And again, I'm going to write out at least 4 after my decimal point, just so I make sure when I add these together, it's like as precise as I can get it. And I get 0, 2, 4, 2. All right, so what I just found was x, my distance from here to here, and then y, my distance from here to here. And they want us to find the distance between the 2 trees, so I have to sit there and find the whole distance. So I'm going to add my x and my y value together. When I do that, I get 29.2639 plus 54.0242. And that's going to be 83.2. Okay. The closest one to that, if I do 83.2, I keep it as it is because 0.2, I round down. So my answer is going to be B, right? If you have any questions on number 8, again, leave a comment. I got you. I will reply back as soon as I can if you have any questions on it and try to walk you through it. All right, so now let's look at number 9. A 254-foot tall radio tower is located partway between a building and a tree. The angle of elevation from the base of the building to the top of the tower is 36 degrees. And the angle of elevation from the base of the tree to the top of the tower is 62 degrees. Choose the appropriate value for the distance between the building and the trees. So for this one, again, we want to sit there and draw this out, okay? So imagine we have a building right here. Okay. Just these are the windows of the building. Doesn't have to be the most perfect drawing, but that's our building. And then we have our radio tower. This will be our radio tower. All right. And then we have a tree, okay? Because that radio tower was in between our tree. So we draw that out. All right. Now they said our angle of elevation from the base of the building to the top of the tower. So from our base to the top of the tower is 36 degrees. So remember, angle of elevation is when we're looking kind of like that. Okay. So we'll sit there and call this our ground. Let me make the ground a little bit more straighter. Sorry about that. A little bit more straighter. Yeah, that looks a lot better. Okay. Because remember, angle of elevation is kind of like when we're looking from the ground up to that angle. Okay. And then we sit there and have it says from the base of the building top, and this was 36 degrees. Yeah, that was right. 36 degrees. And the angle of elevation from the base of the tree to the top of the tower, from the base of the tree to the top of the tower, like this, is going to be 62 degrees. 62 degrees. 62 degrees. Okay. And then they also gave us that the radio tower is 254 in height. 254 feet. Okay. So whenever we have something straight like that and it hits the ground, we can assume it's a 90-degree angle. All right. So again, we're going to sit there and have to use our trig to find the distance between the building and the tree. I'll mark this one as my X and this one as my Y. This is going to be very similar to the one we just did. Let's go ahead and mark up my sides. Opposite from my 90-degree angle is going to be my height. Opposite from the angle that's given, this is going to be my op. And down here, my one left is going to be my adjacent. Okay, so it looks like we're going to sit there and be mostly dealing with adjacent because we're trying to find our adjacent and our op. So it's going to be tan again, right? So I'll do it over here. So the first one is going to be tan of 36 degrees equals op over adjacent, which is 254. We don't know what our adjacent is. We're trying to find it, and we labeled it as X. Okay. And then again, we have to do it for this as well. All right, so that's my or this is my height. This is my op. That's my adjacent again. So I do tan of 62 equals 254. Divided by y, which I don't know what my adjacent is, right? So this is just like the one that we did above, right? So I'm not going to go step by step with the algebra on here. I'm just going to explain it and write it down just for sake of time. So I can multiply both sides by x. That's going to give me x at tan 36 equals 254. I divide both sides by tan. Again, if you don't understand the algebra or how I'm getting this, look at how I did the previous one, okay? Because it's just like that. So in my calculator, so I'm going to have, when I'm going to plug into my calculator, is 254. X equals 254 divided by tan of 36. We got there using algebra. And my y over here, okay, again, how I'm going to how this I is isolated, I multiply both sides by y, then I get y tan of 62 equals 254, and then divide both sides by tan of 62. So then after I do that algebra, 254 divided by tan of 62. Okay. We plug these into our calculator because now this is all calculator work. All right. So on my calculator for tan of this, I'm going to get 349.601. And I'm just writing 4 outs after my decimal point, so I make sure I get it right. And then for y, I'll get 135.0541. Okay, perfect. Again, we're trying to find the distance of x and y on the space, so I add these both together. When I add these both together, I am going to get, I believe, let me see what I got. So 349.6010 plus 135.0541. 48 or 484.6. I'm going to round out up because of that 6. All right, so it's going to be 485, I believe. And 485, so the answer is going to be A. Okay. If you have any questions on number 9, again, leave a comment. I will get back to you as soon as I can. All right, let's do this last one in this video. It's going to be number 10. For number 10, a bird sitting on the top of a signpost, notices a piece of food on the ground, 11 feet from the base of the post. Choose the appropriate distance that the bird will have to fly to reach the food, given the bird looks down at the food at an angle of depression. So this one's going to be a little different because we're doing an angle of depression. So as usual, let's go ahead and draw a picture. So let's imagine we have a little bird. Okay. I am not an artist, so let's just call that a bird. Okay. And so there's a piece of food on the ground. We'll sit there and say that's the food. All right. And so they want to know the distance to get to that food. So from here to here, that's like 11 feet that they told us. Okay. 11 feet from the base of the food. So that's 11 feet. And again, we're talking about an angle of depression, okay? Angle of depression is right here. You're looking from here and down, okay? That's why I drew that 11 feet up there. So from here to here, okay? So this angle is my angle of depression. And I said my angle of depression is 39 degrees, okay? Sorry, that looks like a 0. We'll keep it like that, 39 degrees. All right. So let's sit there and see if we can find it. Let's draw that in right here. We'll make that our 90-degree angle because that's going straight down to the food. And we're going to use trig to solve this, okay? Let's mark up our sides. Opposite from my 90-degree angle is my height. Opposite from the angle given me, that's my op. Whatever's left over is my adjacent. So again, this one's going to be a little bit different because I'm using my height and adjacent. So remember from SOHCAHTOA, that what trig identity is going to use height and adjacent, it's going to be cosine, okay? So cosine of the angle they gave me, which is 39, equals SOHCAHTOA. I even have to look sometimes, adjacent over height, okay? So that's adjacent, 11, over my height. And I'll mark my height as x, okay? Just a second. I gotta grab my phone charger. All right. Sorry about that. My computer was gonna die. Okay. So now I have to sit there and use algebra to solve. Multiply both sides by x. Okay, I get x cosine of 39 equals 11. Divide both sides by cos of 39 to isolate my x. I'm going to get x equals 11 over cosine of 39. This is all calculator work right here. You plug this in your calculator. When you plug this in your calculator, I'll show you guys really quick. Make sure you're in degrees. I do 11 divided by 39 of cosine. That's going to equal 14.1543, which is C. Okay, because we just found how far the bird flew, our hypotenuse, to get from the top flying down to his food. Okay, so I'm going to go ahead and stop here. Again, if you have any questions, leave any comments, and thank you guys for watching.